Okay, today's lesson, day 2 of Unit 8, is similar to the first day. It's the area between two curves, but this time we're looking at things in terms of y with respect to y instead of with respect to x. So just to recap from yesterday, if I wanted to find the area from A to B with respect to x of some curve, then that would tell me the integral from A to B of f of x would tell me the area between that curve. So what we're going to do today is we're going to look at with respect to y. So instead of being on the x-axis, our A and our B are going to be on the y-axis. Our curve may look similar. So again, it's going to go here, here, and then this is going to be, instead of f of x, this is going to be some function f of y. So the integral from A to B of f of y dy is going to tell us the area between the curve and the y-axis. And then between two curves is going to work very similarly. If I have two curves, and I want to go from A to B, let's call this f of y, let's call this g of y. The area between those two curves is going to be the integral from A to B, and this time instead of top minus bottom, we're going to go right minus left, so f of y minus g of y. So that's how it's going to work. It's going to work very similarly. Instead of equations though looking like y equals x squared, they're going to look more like x equals y squared. So your function is going to be in terms of y instead of in terms of x. So let's take a look at the first example. So it says find the area between the function x plus y equals 4 and the y-axis from y equals 1 to y equals 4. So they're telling us they want to go from y equals 1 to y equals 4 of this function. So they want to find this area. Again, this is not between two curves. This is just area under the curve. So since we're doing things with respect to y, we need to write our equation as x equals something. So instead of x plus y equals 4, we're going to subtract y from both sides. And this equation is going to be x equals negative y plus 4. This is going to be the equation that we use to take the integral of. So the integral we're going to take to find that area is we're going to go from 1 to 4 of that function, negative y plus 4 dy. Alright, so the integral works the exact same way. The integral of negative y would be negative y squared over 2. The integral of 4 would be 4y. We're going to evaluate that from 1 to 4. When I plug in a 4, I get 16. So negative 16 over 2 is negative 8 plus 16 minus, and when I plug in a 1, I get, let's see, negative 1/2, and then plus 4. So I have 8 minus 3.5 or 4.5. And we can verify that pretty easily by finding the area of this rectangle. The area of this rectangle is it's a triangle. It is 3 height, 3 base. So 1/2 base times height. 1/2 of 3 times 3 is 4.5. So that is how you find the area with respect to y. So let's take a look at another example. Find the area of the region bounded by the graphs of negative y squared plus 4 and the y-axis. So again, they're looking at the area here. This is another simple area under the curve function. So I'm going from -2 to +2, so that's going to be my integral of -y² plus 4 dy. So the integral of -y² is -y³ over 3 plus 4y, evaluated from 2 to -2. So let's plug in a 2. I get -8/3 plus 8 minus, when I plug in a -2, I get +8/3 minus 8. So -8/3 plus 8 minus 8/3 plus 8, or 16 minus 16/3. And I don't know what that is without the use of the calculator. So really quickly, 16 minus 16/3 as a fraction is 32/3, or approximately 10 point, rewrite that, 10.6 repeating is the area under that curve. All right, example 3. In example 3, this time we're going to find the area between two curves. So we're going to need to graph these. So you're going to recognize that things graphed very similarly. So in this case, this is a negative parabola, so it opens to the left, and it's shifted to the right 3. So 3, and it opens to the left. X equals y plus 1, that is the same as y equals x minus 1. So that would be minus 1, like that. So this is an example where we want this area here. We need to know where they intersect. So I need to, step 2 is to figure out where these two things meet. So I'm going to move this stuff over to the left, to the right side. So I'm going to get y² plus y, and then minus 3 gives me minus 2. I'm going to factor y plus 2, y minus 1. So it's at -2 and positive 1. Again, we're looking at y values here, so that my y value down here is -2. My x value up there is positive 1. So let's do the integral. So the area is going to be the integral from -2 to 1 of the right minus the left. Well, the right is the quadratic, so 3 minus y², minus the left is the linear, y plus 1. Let's clean that up before we integrate. So we get -y² minus y plus 2. So we end up with -y³ over 3 minus y² over 2 plus 2y from -2 to 1. So let's plug in a 1. I get -1/3 minus 1/2 plus 2 minus, let's see, I get 8/3 minus 2 minus 4. And again, I'm going to need a calculator for that. -1/3 minus 1/2 plus 2 minus that quantity of 8/3 minus 2 minus 4. gives me a total of 4.5 again. So